Algebra 2, Lesson 33, Part A is called Major Rules of Algebra, and we're focusing on 3 rules that we use a lot. The first 2 are for solving equations, and so the first one says the same quantity can be added to both sides of an equation without changing the solution. Okay, we use that a lot when we're isolating variables. And we also use this one. Every term on both sides of an equation can be multiplied or divided by the same quantity, but not 0, without changing the solution of the equation. All right, but what we're going to focus on in this lesson is the third one, because we'll be dealing with fractions. And that one basically says whatever you take times the denominator, you also must multiply that by the numerator in order to keep the fraction equivalent. Not 0, but anything else. Okay, so here are some examples of when we use that denominator-numerator rule. One is when we are adding fractions, when we're adding rational expressions, like in example A here. For this, we're looking at these denominators, and the common denominator is going to be x times x plus y, because one factor will be from this denominator and the other one is that denominator. Whenever I multiply times the bottom of this fraction, I must also multiply times the top. Likewise, on this other fraction, we're multiplying x plus y over x plus y times this one. Okay, and we actually multiplied those numerators. So we get 4x from the first one here, plus, and then we have py times x, plus py times y is py squared. And that is all over this common denominator of x times x plus y. We do multiply in the numerator and see if there are any like terms to be added. And then after that, that's pretty much it. You do not need to multiply the denominator. There may be cases in the future where your fraction will reduce, and in order to do that, you want it to be in factored form so that that's easier to see. So that would be A. That's adding rational expressions. Another time we may use the denominator-numerator rule is when we're simplifying complex fractions, which this is getting us into Part B then. All right, so what we have here is one fraction divided by another fraction. And the way we use the denominator-numerator rule for this is to multiply the top of this complex fraction and the bottom by the reciprocal of the bottom. Okay, so, whoops, I didn't want to be there, I wanted x. The reciprocal of b over x is x over b. So I multiply this complex fraction by that complex fraction, but it's going to simplify, because down here in this bottom part, those b's cross cancel. You basically have bx over bx in the bottom. That reduces. You can think of it as cross canceling, or just multiply them and then, oh, this is the same thing divided by itself, so that's equal to 1. Okay, then we just multiply these. So a times x is ax, and then we have b times x plus y. Make sure you put the sums in parentheses. That is very important. That's all that reduces to. Okay, now you can simplify this kind without using the denominator-numerator rule. And I wish that would focus better. There we go. And so if that seems a little confusing to be multiplying by that complex fraction, your alternative, okay, so alternate method, just for the second one here, for B, would be to rewrite we had this division problem was written vertically, we can write it horizontally. So a over x plus y originally was being divided by b over x. And you hopefully remember that when you divide by a fraction, the way to actually finish that is to multiply by its reciprocal. So this would be a over x plus y times x over b, which is exactly what we did over here in the numerator. So it still gives us ax over b times x plus y. You get the same answer either way, so it's just whichever way you prefer to do it. Okay, now part B. It's more things that are, well, kind of combining these. We have a sum where we're adding fractions, and we also have a complex fraction. Okay, so we're going to work on these in parts. First, we want to simplify this numerator, and the denominator already is as simple as it can be. So we'll simplify the numerator, and then we'll simplify the complex fraction. So in those two fractions in the numerator, they need to have common denominators, and it looks like it's going to be xy. This second fraction already has xy as its denominator. We just need to multiply x over x times that first fraction. Okay, so we have x squared plus 4 all over xy. And now that is over a over y. And again, whether you want to multiply by a complex fraction or write this out horizontally first, it's entirely up to you. For right now, I'm just going to multiply by the complex fraction. Okay, so just flipping this one, and then multiply times top and bottom. Those cancel. These y's even cancel right there. And so we are left with x squared plus 4 over ax. And that's as simple as we can get that one. Okay, so for the next one, it's pretty similar. Just have a little more going on in the denominator now. So we need to take y over y times the first one, and x plus y, again, write the sums in parentheses, x plus y. Okay, again, I'm just simplifying this top part first. And let's see, we have ay plus, and we take m times x, and we take m times y, and that is all over y times x plus y, which again, I don't want to distribute that because maybe something will simplify whenever we take care of the next step. I have x over a plus m. It won't simplify on this one. Alright, so now we multiply the top fraction by the reciprocal of the bottom, because that's what we do to the bottom to make that cancel. Whatever we do to the denominator of our complex fraction, we must do to the numerator. Okay, and I should write these things in parentheses. Alright, so now I'm going to go over here, and we have a lot of things to multiply. Actually, I'm noticing the book doesn't make you multiply that out, so I guess I won't either. We'll just write it nice and neat. We have ay plus mx plus my times a plus m over xy times x plus y. And that's that. And the end of the notes.